Our paper is a question versus sentence selection for question generation. This work has done at a data mining lab at York University. The first, what is the automatic question generation? In this, for the question generation, we want to train a model, which this model learn to ask a question. For example, we have the model and we want to the input of this model is a sentence, and the output of this model is the question. So if we want to design this model which can generate the question automatically for us. The application of the question generation they use for the chatbots and the smart conversational system for the educational environment. Also, it has used a lot for the reading comprehension assessment. One of interesting application of the question generation is we have they use for the when we have an image and the human can ask lots of questions from the image automatically, like when we show this image to the human, this is the possible question a human can ask. For example, a human can ask who made that candy cake. So we want one of the application for the automatic question generation is the training a model which this model learn to ask question like a human. In our work, we collaborate with the Inago company, and they wanted to generate the question that which used for the chatbot interface or AI conversation assistant. The data we work on that is a car manual. They have some data about the car and the all manual of the car, and they want to generate a question from these car manuals. Before they use the higher human to generate the question for them, but recently they use some they want some models which can generate the question for manuals, and one of the very famous model for the question generation is a sequence to sequence. As we know, the sequence to sequence models they have used for the language translation. In language translation, the input of the sequence is for example, a sentence in a source language like French, and the output is a sentence in a target language like English. So, and for the how we can use the sequence for the generate the question is the similar. We train the sequence model with a pair of the sentence and its corresponding the question. The input is a sentence and the output is in the question. So by this way, we can use the sequence to sequence model to generate a question. But the language translation and the question generation, they are similar, but they have lots of differences. For example, if you look at the output question from this model, you see lots of words they are common with the original sentence. But in the translation, we don't have the output and input, they don't have overlap. They don't have any overlap. So, and also for the translation, mostly the length of the output is same to the length of the input with a little difference. But here we don't know the sentence is longer or the question is longer, and they have lots of difference. So One of the methods which in the question generation field they use to increase the performance of the sequence model for the generating the better question is using the paragraph. We can use the paragraph as a context, and we include this context into the sequence model, so the sequence model can train better and using this external knowledge to generate a better question. But the problem with the paragraph sequence model is the paragraph also always is long and have a lots of irrelevant sentence to the input of the sequence. So which makes it really hard for the sequence model to train and learn and generate a good question. For example, in this paragraph, we see the some highlight part of this paragraph. The all possible question from this paragraph comes from the just this highlight section in the paragraph, and we call other sentence are relevant to the question. So in this work, we are going to extract this highlighted of the paragraph, which is when we extract all these important sentence as a question worthy sentences, so we make the paragraph shorter, so the sequence have a really rich and important context which we can use instead of using the whole paragraph. We use the important sentence of the paragraph as a context, so makes the sequence works better. In the challenges, there are two main challenges with the car manual data which we have for the Inago company. First of all, we know the sequence model needs lots of training to train very well. But in the car manual we have a small training set, so when the number of the training set is small, so the sequence model cannot train very well, and so it cannot generate a very good question. Another problem with the car manual is there are lots of irrelevant sentences, so before we generate the question, we have to remove all irrelevant sentence and just use the important sentence as a question worthy sentences for the generating the better question. As you see in this slide, we label the sentence in the car manual in two categories, 1 and 0. 1 shows this sentence is a sentence which human most likely ask a question about, and 0 shows the question the human don't want to ask a question from this sentence. For example, this sentence is make sure all doors and windows are completely closed, so there is no question here. So we know we have some sentence which they labeled into 1 and 0. 1 question worthy sentence, it means there is possible for human to ask a question here, and the 0 means they are not. But the car manual has a lots of these 0 sentence, and if we include all these 0 sentence in as a paragraph and context for the sequence model, so the sequence model cannot train very well. So one of the first method we tried is a summarization method, because in summarization method also we know some summarization method they rank the sentence based on the how much information they have. They are good sentence to include in summary or not. So But the problem of the car manual and generating the question is different from the summarization method. For example, as example, you can see here we have this paragraph, and the first sentence, if we give it to the summarization method, most of them they extract the first sentence as an important sentence which say the summary of this paragraph or manual. So but for the question generation, this is not a good sentence which human ask question about. Just this highlight part, they are the question, they are the sentence which the human can ask a question about. So that they are different, but there are also some similarity for the ranking the sentence. Uh, so what we did is we look at the data or car manual, as you can see as an example. For example, there are lots of the sentence just they have one word or one verb. We know they are not a good sentence and they are not a rich context. So and also if you look at the sentence, you can see mostly the long sentence they are ranked, they label with one. They are most likely to ask a question about. So when we look at this data, we are motivated to generate, to propose a method which we call it feature-based question versus sentence extraction. So first for all the sentence we make some feature. So features can, the first is said because this work is similar to summarization method. So the first features, there are the ranking feature. We run for summarization method, and they give us for each sentence a rank, and we extract of our rank and normalize them for the whole document and take them as a ranking features. For the post-tag features, we look at the sentence. For example, the number of verbs is a feature. The number of nouns is a feature. The number of the adjective or adverbs can be the feature. We extract some feature like that as a post-tag feature. Also, we use TF-IDF for each sentence as a one external feature, and also the length of the sentence and the stop word ratio of the sentence. So by this way we can see how much information each sentence has. The feature says how rich this sentence is, because when the sentence has a most important and rich context, so the human possibly more likely to ask question about. So we give this feature to the classification. We use the random forest classification and give to the and extract the question versus context. So this classification classify this whole sentence in the document in two different classes. One called one as a question versus sentence, and irrelevant sentence as a zero. So we ran this method on for the squad dataset. The squad dataset is a popular dataset which we have the paragraph corresponding to each sentence, and the squad is used for the question generation. As we can see, the our method called FSSM is better or the than other baselines. Also, we analyze, for example, this is our method just considering TF-IDF or length of the sentence or something like that, and we analyze this result here and show the result for the just considering the post tag features or just the ranking from the summarization to see how much they are different. But as we can see, the combine all of the feature gives us a better result. And also we run it on the car manual, and we see the same pattern for the result or our car manual. After the generating the question worthy sentence, so what we need is include all these question words this sentence as a context into the sequence. For this we use a special attention model, which this attention model is possible to include the contents for each input. So we add these contents by the attention to the sequence model. So the next step is to see by adding these important contents into the sequence model how the sequence model works. As we can see, we run it to generate the question for the squad, and we compare with the other baseline. As you can see, this is, for example, this is para sequence to sequence is when we use whole paragraph in sequence, but this is our method FSSM, just using the important sentence as as a context. As we can see, the result our proposed methods are better from the other baselines. And also we run it on the car manual also, and we see the same pattern for the car manual dataset. So in this work, we extract some important sentence from the manual and data, and we use it for the sequence to sequence model, and we can see that this can increase the performance of the sequence model for the generating a better question. Thanks for your attention.